All right, guys, so in chapter 4, we've covered quite a number of things. I do want to leave off this chapter with one last technique of circuit analysis that's quite important. In this class, it might not be as essential as later classes. However, it's important that we cover it now using DC circuits rather than AC circuits so that you get some practice. Right? The last technique of circuit analysis that I want to cover is called the technique of superposition, or the principle of superposition. So the topic is the principle or technique of superposition. Now, superposition itself is something relatively simple. And it states that given a linear network, any circuit voltage or circuit current may be calculated as the algebraic sum of the individual voltages or currents caused by each independent source acting alone. Right? That's important enough to write down. So let's go ahead and write that. It states that given a linear network, any, and I do underline any, circuit voltage or current may be calculated as the algebraic sum of the individual voltage or currents caused by each independent source acting alone. Now, in terms of the wording, there are a few things that I really need to bring to your attention because there are certain limitations. The first one is only independent sources may be shut off. You cannot shut off dependent sources. The principle of superposition will not work if you shut dependent sources off. So only independent sources may be shut off. Dependent sources cannot be shut off. A second thing, and this is again in terms of the wording, this technique itself is only useful in analyzing circuits that contain two independent sources or more. If your circuit contains one independent source, whether it be a voltage source or a current source, this technique cannot be used in order to analyze the circuit. Right? So superposition is only useful if you have two or more independent sources. One last thing that I want to make mention of before I talk about how it is that you shut off voltage and current sources is that this technique is not nearly as useful for analyzing DC circuits as it is either AC circuits or circuits that happen to have variable inputs, right? Voltage and current inputs. In fact, superposition itself is not just useful, it is absolutely foundational. It is one of the fundamental cornerstones of all of electrical engineering. You cannot theoretically get away from superposition, right? This is one of the reasons why we want to practice it using DC circuits, which are much simpler than using either AC circuits. Later on, one of the things that you'll learn about is things like Fourier series, where you deconstruct various voltage inputs or waveform inputs into an infinite sum of sinusoidal sources. And if you want to predict what voltages and currents are going to be within that larger circuit, superposition is again absolutely fundamental, right? So here, this technique is more useful for AC circuits than for DC circuits in general. Not always, but in general. Now, let's talk very briefly as well about what it means to shut off sources. When it comes to turning sources off, there are two separate sources that we actually have. And every time we shut off a particular type of source, we're either going to replace it with either a short circuit or an open circuit, right? So here, consider voltage sources. So our voltage source, suppose that it looks something like this. It has this particular polarity, and there's a voltage across the two terminals, right? Now, in general, this voltage source can have any arbitrary value. It can have 1 volt as a value, 2 volts, -3 volts, anything that you really want. However, if you happen to shut it off, right, so that you turn the dial down all the way down to 0, the only thing that you can actually say about this element, right, is that the voltage across its terminals must be 0. There's only one other circuit element that has the property that the voltage across its terminals is 0, and that happens to be a short circuit. So over here, if you shut off an independent voltage source, one of the things that you will replace it with is between its terminals a wire / short circuit. Why? Because for this short circuit, the voltage across its terminals is guaranteed to be 0. Right. Now, for the second independent source, we have current sources. So here, suppose that you happen to have a current source, and it has two terminals A and B, and let's say that there's a current flowing from A provided by the current source all the way to B. Now, in general, this current source is going to have some value, maybe 1 amp or 10 amps or -3.5 amps, whatever it happens to be. However, if I turn the dial on that source all the way down to 0 amps, there is only one equivalent circuit that guarantees that the current flowing through its terminals is absolutely 0, and that happens to be an open circuit. If there is no wire connecting terminals A and B, that's an open circuit. This guarantees that the current flowing from terminal A to terminal B, well, that happens to be 0. Right? So anytime we shut off a current source at the terminals, we will replace it with an open circuit. This is enough theory for superposition. In a few videos, we will go through some examples to see how it is that superposition itself can be applied in order to analyze circuits. Thank you.